So hi everyone, I'm Uri. Today I'll be presenting my recent tackle paper, Serving the Landscape of Image Captioning Evaluation, a Comprehensive Taxonomy, Trends, and Metrics Analysis. Eventually it'll work. Yeah, okay. This is a joint work with Gabi Stanovsky and Omri Ben from the Hebrew University of Jerusalem and Leah Furman from the University of Melbourne. The motivation to this work came to me while I was developing an image captioning model. I asked myself, which metrics should I use? So I started by asking, which metrics did previous studies use? And when looking at previous studies, I got the feeling that everyone used these 5 metrics: blue, meteor, rouge, spice, and cider. However, I also got the feeling that everyone say that lexical similarity metrics are really bad. Here are 2 examples. But still, 4 out of these 5 are lexical similarity metrics. Okay, I said, so let's use other metrics that best fit my current project. But it feels like every week or two there's a new metric out there, and it's really hard to keep track. I really wish that someone would create a catalog of all existing metrics. Finally, say I do have a catalog of all existing metrics. Which one should I use? For example, consider this image, and let's consider the caption, a red plaid blanket. Now, most of the people would probably focus on the books and not on the blanket in this image. So metrics that evaluate the similarity of the candidate caption to a reference caption would probably give a low score. However, there is indeed a red plaid blanket in this image, so metrics that evaluate the faithfulness of the caption would probably give a high score. So given that different metrics evaluate different aspects, which one should we choose? Maybe the best path here is to combine different metrics. Now, following all these thoughts, these are the goals we try to cover in this work. First, create a taxonomy of image captioning metrics and categorize them so that metric users can easily select the metric that best fits their needs. Second, show quantitatively which metrics are used the most, and this will show us if indeed the 5 metrics I mentioned earlier are used the most. Third, show which metrics align most with how humans rate captions, where here we expect to see that the 5 metrics are not so good. And finally, explore to some extent the idea of combining different metrics. Okay, to achieve these goals, we survey image captioning papers from previous years. We search for conference papers on English image captioning from 15 leading venues in NLP, computer vision, and machine learning. We find these papers by searching for the substrings caption and description in titles, assuming that most image captioning papers would have something like image captions or image descriptions in their title. After filtering and manually confirming each paper, we identified 314 papers since 2009. We then manually observe each paper and collect data on both automatic and human evaluation. Now, in this talk, I will only focus on automatic metrics, but read the paper to learn more about human evaluation frameworks. Okay, let's start with the taxonomy. Overall, we identified 71 metrics. And again, the goal of the taxonomy is helping metric users easily select the metric that best fits their need. We therefore categorize metrics by the aspect of the candidate caption they try to evaluate, following the thought that when you develop an image captioning model, you want to show that the generated captions are good at X or Y. We identified 4 top categories in addition to many subcategories. The first and largest top category, with 46 metrics, evaluates different relations of the candidate caption with the ground truth source. For example, one subcategory measures the similarity of the candidate caption to a ground truth source, the source being either a reference caption, the input image, or both. One example of similarity to a reference caption is lexical similarity that I mentioned earlier, where you can find 4 out of the 5 metrics that I talked about. And here are all the relations with ground truth metrics. Moving forward, the second top category evaluates the relation of the candidate caption with human behavior, for example, how human-like it is. The third top category measures the diversity in generated captions. For example, one subcategory uses lexical similarity metrics to compare the different generated captions and see how diverse they are. And here are all the diversity metrics. And finally, the last top category measures the bias in generated captions, where by bias I mean biases such as social, racial. Okay, so this is the entire taxonomy. And you might notice the coloring of metrics, in addition to some other weird stuff like this $ here. That's because in addition to the categorization I talked about, the taxonomy contains information such as whether each metric has a publicly available implementation, whether it requires some payable API access, and what's the expected input, candidate only, candidate plus reference, etc. Okay, so this is it for the first goal. And next, we show which metrics are used the most. In this graph, you see the number of papers that used each paper over the years. And let's start with the 5 metrics I mentioned earlier. Here we can see the usage of blue over the years, which clearly increases. Now adding the 4 other metrics I mentioned, you can see that their usage sharply increases around 2014, probably as around this time the first large image captioning datasets were published. Now let's add all other metrics from the relation with ground truth top category. In brown, you see retrieval-based evaluation. In pink, you see clip score. And in gray, you see all other metrics from this category. And you see that these 5 metrics are more common than all others in their category. But what about the other top categories? So let's add them as well. Okay, you can see relation with human behavior in dashed green light, diversity in dotted light blue, and bias in black. And overall, this plot clearly shows that indeed 5 metrics dominate the evaluation of image captioning models. However, we do see some increase in usage of other relation with ground truth metrics in recent years. Okay, so we achieved goal 2, and now for goals 3 and 4, we need to conduct some experiments. The data we're going to use in these experiments are existing human rating datasets, where each sample consists of an image, a candidate caption, and a human rating of this caption. Now we're going to use the image plus candidate caption as input for the metrics we want to evaluate, use the metrics to generate ratings, and compute the correlation between metric outputs and human ratings. Okay, now for the results. In this table, each row presents the results for one metric, where each column shows the correlation achieved on one test set, and we have 5 different test sets. Now, the rows are sorted by the mean correlation across all test sets. Looking at the 5 dominant metrics, you can see that all of them are less correlated with human ratings when compared to more recent metrics, such as clip score and polos. Okay, so we have 5 metrics that everyone used and they're really bad. What can we do? So as I said, since different metrics evaluate different aspects, we might gain from combining them. Where by gain, I mean stronger correlation with how humans would rate these captions. Now, as a proof of concept, we thought of the most simple way we can of combining different metrics, linear regression. That is, for each metric, we learn a coefficient. We multiply it by the value that the metric gave us for this sample, and we sum up everything to get the ensemble score. Now, if we learn the coefficients on one data set, and when using them on other data sets, the correlation with human ratings would improve, this would show that this path is worth following. Okay, so we hold out some data for learning, that is for selecting the coefficients, and we select them to maximize the similarity of the ensemble score to human ratings. And we call the resulting metric ensemble. Okay, going back to our results table, let's add ensemble. And as you can see, our ensemble method is the most correlated with human ratings. And again, the coefficients were learned by training on data, which is not one of these 5 test sets. So why does the ensemble work? Going back to our famous example from before, and now with the reference caption and metric scores, you can see that indeed the candidate caption mentions the blanket while the reference doesn't. Now in this case, polos, which compares the candidate caption to the reference caption, provides a low score. Blip2 score, which measures how faithful the caption is to the image, provides a high score, but while both humans and the ensemble provide a moderate score. Now, if we look back at the experiment results, you can see that both polos and blip2 score were 2 of the metrics that were most correlated with human ratings. So why did they fail here? Blip2 score provided a high score since indeed there is a blanket in this image, so the candidate is faithful. Polos provided a low score since it compares the candidate to the reference, and the reference didn't mention the blanket since it's not the first object that comes to mind when you look at this image. Humans, on one hand, take into account the fact that the candidate is faithful, but from the other hand, that it mentions an object that they probably wouldn't choose to mention, so they give a moderate score. The ensemble simulates this process but by combining the different metrics, and that's exactly the strength of combining different metrics. Okay, so this is it for all the goals, and thank you. You can scan the left code to get to my personal website or the right one to get to the code of our project, where you can find both an ensemble metric as well as create your own ensemble by adjusting the coefficients.
Thank you, Uri. Do we have any questions for Uri?
Hi, thank you for your interesting talk. I have a question on how you obtain the human ratings more specifically. So what kind of questions did you ask the human annotators? How many annotators there were? Did they have like a proper agreement? Because otherwise it's kind of hard to understand what kind of information we get in terms of correlation to the human ratings.
Thank you for this question. I totally agree. The problem is that we used existing human rating data sets. We didn't collect the data ourselves. Each data set had a different instructions for the annotators. They're all in the paper. I agree that it's not the best practice, but it's the best one we currently have. I just followed the same data sets were used by previous metrics. I do agree that we need to find something more robust.
Okay, thank you.